Welcome back, fellow scrubs. This is Mark D. Wiz, and I'm here today with Tim.
Welcome, fellow scrubs.
Yes, Tim is also a fellow scrub. So welcome, Tim. Tim hasn't been on in a while, so if you haven't been here very long, Tim is one of the developers, I guess, in our circle of friends and team and stuff. We worked on Hamster Drop together, and Ecto Rush. And other several secret prototypes that we can't talk about yet. So we're working on this one now.
And I'm the de facto winner of the Make 'em an X race.
Well, we didn't do X3 yet.
Damn it, you got on.
We didn't do X3 yet. I kind of been waiting for it, but then I kind of forgot about it. I'm like, it's been a while, so I don't know what to do.
We don't make a tie.
Yeah.
For now, one.
Yeah. All right. My music thing's not loaded. Hold on. They can hear it. They just can't see the title of the track. I use a program called Snip. Yeah, there it goes. It's a program called Snip, and you can configure it to pull the title out of Winamp for whatever reason. That's its primary purpose, I guess. It sends it to a text file, and then XSplit reads it.
So you can read amazing you can read amazing titles like Name Entry.
Yes. Yeah. So, turning the music up for me. I like this one. Okay. All right. I think we're all set. Audio should be fine this time, like it wasn't last time.
And I'm also audible, so it helps.
Yeah. Alright, so we're working in the Mansion game. Essentially, we're doing programming engine. Or programming engine. Platforming engine.
As you can see, there's a mention right there.
Yeah, there's a mention. So we're doing a platforming engine where we're walking up slopes and stuff. And it's multi-purpose, so it'll be used for the Mansion game. And we're going to be specking out things that are like way past what we need for the Mansion. But we figure we might as well get it done now, and then we can reuse it for other projects. So that should be fun. I thought
you fixed the debug features.
Yeah. You can see the players.
Well, that is, but the line readout is wrong.
Oh no, the line readout I didn't change that. I just changed the local space view so that you can.
Would be nice if it worked.
Yeah, I don't know. It might be too much to do that and actually get something done in the stream, but if we happen to need it, I guess then we'll go from there. Or you know what I could do? Actually, I might be able to do this quickly because we already collected the data into that line ref, and so we can get a readout. But yeah, before I do that, we'll load Visual Studio just to get it there. So what
you might want to explain what it's always.
Yeah. So what we have so far is let me restart it. We'll pause it because you fall at first, and so here's the Poly Collider in Unity that we're using to test. We're also testing with the different shapes and stuff. So you're falling, and you're raycasting while you're falling down until you hit the surface of something, and then boom. Now you're attached to it, and so it will get debug rendered this thing you're walking on, and it tells you, okay, you landed on this line segment, and these points from here to here, but then it draws the whole shape. And since this is a rotated shape, we have rotated it. I don't know what, negative 161 point something degrees. We scaled it and all that to make sure that all that worked. So the actual shape itself originally in 1:1 scale looks like this. And so the yellow is basically where we are now. The white is where we collided with it initially. It's paused. And so we can see like where on the shape it really is. So it moves along the side there. And so we've got a bunch of debug readouts. The code's an absolute mess because we're just going through it right now. And the idea is right now we can walk between these points. So once we're on a line segment, it's like, okay, if you press left, you're going toward this point. Press right, you're going toward this point. And that's what we got so far. Then once you reach the end of the line, it checks for the next segment, and it allows you to go through.
Yeah, so the initial debug line it places there, that was based on the raycast, right?
Yeah, so once we're attached to the line, we're actually not raycasting anymore. We will have to eventually, and we're going to do that tonight. But the initial raycast doesn't have to be done anymore because we've attached to the collider. Now, if the collider moves while we do this, of course, it's going to get all wonky and messed up. So we don't have, that there. But, this is... Well, we're on, day 6 now, trying to get this stuff to work. So it's a big process. It's a very prototype now, and we're just kind of... I wouldn't say that we're winging it. We kind of have an idea of what we want it to do. But, this is our first outing in making a really, actual... vector-based platforming. By that I mean it's a line in space. It's not pixels. You're not measuring pixels and doing that shit. It's literally a line. You can zoom in forever, and it's points in infinite space, as opposed to actual pixels on the screen, and you have to treat them much differently. There's a lot more math with vectors.
And the idea behind this was that we can handle slopes properly.
Yep.
And rotations.
Mm-hmm. So you think of something like New Super Mario Brothers Wii or Wii U does this kind of platforming, where they could take the box and just start rotating it in real time, and it doesn't matter what the slope angle is. The player will always be able to walk up on it, and so that's the idea, and that's why we've got this weird shape here where he's just walking up different slopes. He has to be able to handle everything, and if he doesn't, then no bueno. We're back in the old days. They had usually preset angles to their thing, which actually I probably should open the file you sent.
Can you open it?
I can, but it gave me an error, so I don't know if it's showing correctly or not. So I kind of bypassed it.
Oh yeah, it looks fine.
It does? Okay. So back in the day, you could just say, oh, we've got a 45-degree angle slope, we've got, I don't know, these are the angles, I guess, 26.5.
Yeah.
And you would base them off of how many pixel stepping things you... Pixel steps you do, so this is, one up, one down. So you're going, one to the right, one up, one to the right, one up, that's your 45. And you could program that easily in older systems, because it's okay, all the angles are predefined. You're not rotating things, because you can't rotate things like on an NES. You could do it on an SNES, but I highly doubt many games used it. Castlevania 4 did, but I don't know how janky the code is under the hood for that kind of thing. They only did it in one room, so I have a feeling that they kind of ghettoed it. Just it works. Good enough. Alright, we can't do this anywhere else because there's not enough power on the system to do this. But we did it in one room, so we can check that off on the marketing checklist.
The problems we had is that once you arrive in old school style, once you arrive at the peak of a slope, you basically fall for a nanosecond.
Oh, that was in the old vector system that we tried. The way that I solved it in the pixel-based one is the fact that you have a literal grid, and you say this tile ID corresponds to a tile that has this physical shape, and then the other one has this physical shape, and I could just look at the next tile because it was a literal grid, a literal array of data, and I'd just look at the next tile in the array, and I'd say, what is it? Okay, cool, and then I'd make a pre-programmed intelligent transition to go from the top of this to start back down on this. And
but where we ultimately want to go to is not a grid system, but a freeform system.
Right, and that will allow you to do crazy dumb shit like how this is overlapped with this. Now, right now, we don't have the functionality to transition to the new one. We're going to try that today, so that's why I thought that might be an interesting, exciting little thing to show off. So the idea is that maybe even this poly collider could even be moving into the space of this other one, rotating or moving, and then you could just walk from one to the other once you reach a certain point. And so you can't do that in the old systems. It just don't work like that. There's very limited tricks that you can use to do that. So you say, oh well, Super Mario World has like two planes that can go, like there's a floor and it's pushing you up through the level or whatever. But they use tricks to make that work properly. It's not something that works quite like a vectored system.
In this case, also, if this collider you're standing on, this floor you're standing on, would rotate around and start moving itself,
right?
It would keep you on that floor.
Yeah, so that's going to be another that's a whole different story. But yeah, so when this thing rotates, yeah. So when this thing's rotating or moving, it will carry you along with it. So, and all that's possible using the vector system. So you can think of like, it is a 3D game, but Super Smash Brothers does similar kind of platforming. And you know how they have rotating stages and stuff like that. It's the same thing, because this concept translates to 3D fairly, I wouldn't say easily, but the concept of how it works translates pretty well to like 3D, because you're already using vectors. Then you're just adding another dimension on top of that.
So we came up with the idea of going 3 points and calculating the angle, tracing that line, right?
Yeah, so what happens when we currently, let's close that, and I'll close that for simplicity. So this line ref represents the current line that you're on. So we know it's this poly collider. It stores the collider. It stores what point in the collection here. So each of these dots is a point that make up the shape. It stores what 2 points make up this line. So 0.8 and 0.9 make up this line from here to here. And then this one, see it change. This is 7 and 8. Let's get over here. A straight line. So this line here, this is 0.11 and 12. And then so it gives us the where they are in world space. So that's how it knows to draw these. And then it gives you the angle. So we've got negative 15 as an angle. And the scale sign, oh, that's for, yeah, don't worry about that. That's just for, because you can scale things negatively. And we were having problems with that too. But, Unity's like, well, you can do it. And I'm like, well, alright, we need to compensate for it then. That's what that means, that the scales are both positive or negative. Yeah, so they're not negative, so they're unchecked. So it's sort of like a status, so that we can see what's going on here. And that's how we move. So when we press left, we move toward, I think it's point B. So that's the one that's more.
The idea with this being that you can only travel between those points.
Yes.
So once you're on a collider, you cannot go inside it anymore.
Right.
You're following the lines perfectly.
So we have two states right now. We've got a falling state and a grounded state. So while we're falling, we're not attached to anything. But as soon as we touch this collider, we are glued to it, or at least its mathematical location. You're no longer affected by gravity and stuff like that. Like, you're just literally snapped to it. And your movement goes from, just plus and minus X to literally moving toward one point or the other. And so far that's been working out. So that seems to be the way to go.
And the reason addition was that we cannot proceed beyond a certain angle.
Mm-hmm. Yeah. So you may have noticed I'm stopping at the end here, but I'm actually not stopping by will. It literally says, hey, you can't walk on something that's, we set it to 78, that's greater angle than 78. And so we actually have where it says attempted line ref. That's actually looking at the next line here. And so the angle here is negative 111. So obviously it compares only a positive value. So it compares positive 111 and says it's bigger than 78, so you can't do it. And that's...
Yeah, set it through 360 for once? Or 180?
Oh, yeah. I think 180 allows us to walk around it. Yeah, and so now you can walk around it. Of course, your controls are reversed when you're upside down, but... So right goes left, the left goes right, but...
Your debug readout is flipping out, by the way.
Oh, it is? Where? Which one?
It's showing in the wrong direction.
Where?
Below it.
Where?
The yellow line below the player.
Oh, it's showing...
It's running reversed when you're upside down.
Yeah, it is.
That's funny.
Yeah, because you're not meant to go upside down, so I guess that's just the way that works.
Curiosity?
Yeah, not sure. Not sure why exactly. But we're not meant to go upside down anyway, so...
Probably your right to left flipping. You're upside down.
Oh, yeah, could be. Could be. But it's no longer...
Might need to be solved eventually.
But it's no longer pointing in the direction that you're going, but it is when you're on top. I don't know. Anyway, we're not allowing you to do that. It's
going in the direction you're pressing.
Yeah. Yeah, I guess so. Yeah. Wait, let me put it back 180. Is it? Oh yeah, you're right because I'm pressing left, so it's showing it to the left. You're right, and that's the correlation. But since the movement is reversed, it's just weird that way. Now back to the top.
He's walking the ceiling now.
Yeah, he's walking the ceiling. But obviously, yeah, we don't want that to happen anyway, so keep the walking angle at a reasonable rate. I guess we might maybe have to put in a hard limit of 90 so that you can't do 90-degree walking.
So,
ever.
Try flipping the collider and show that for a moment.
Maybe.
The other collider orientations.
Oh, yeah. So we can rotate this thing, and it will still work fine. Let's see there. I think it'll go down this last bit here. Yeah, should be just sharp enough. And yeah, obviously we can't rotate it in real time, like I said right now, but we can.
Yeah, that function is missing.
Yeah. Because once it calculates the line, it doesn't update it, but we'll get to that point eventually. But right now it's not.
This one's cool on the side like this.
Yeah. So again, yeah, see, it just picks right up, and it's just reading lines and line angles, and it's just moving you between the 2 points. And then once it gets to the end of the point, it just says, hey, do you want to move to the next one? Cool. All right, we're going to read this line information. If everything looks okay, you know, like the angle is acceptable and all that, cool, then we'll put you on that line, and now you're moving on that line. You can just go back and forth, back and forth.
Yeah, so eventually we're going to move this towards, if you hit the edge, you go into a falling state.
Yeah. Yeah, we're like a couple episodes ago on the stream, I talked about how Mega Man X does its system. We're gonna try to do something that mimics that, and on the edge, like the way that you behave when you start walking off. I think that's probably the optimal way to go, and not only just from a standpoint of gracefully transitioning between two different colliders, but also the way that that will feel to the player should be the optimal way to go. So gameplay-wise, I still think it's the best decision. And so we want to try that.
If you look right now at the rotation of the collider, for example, this looks like an actual mountain scale.
It kind of does, doesn't it? Yeah.
Yeah.
Yeah, so if we could fall, we could fall off the edge.
It.
We can't. Yeah. Not yet, at least.
Yeah, not yet.
Notice that the rotated shape, the local space is unrotated, so this is the original pristine shape. And we're actually using our calculations in local space for the most part. So we take our position here and then boil it down to a local position, which is what this represents. And it's pretty accurate, as you can see. Even this close, you can't see any floating point aberrations. So
yeah, try scaling the x-axis on the collider.
Sure.
Live.
Oh, live. Okay. Well, you can get to the end of the point where it thinks it is, and then it will recalculate, I believe. But it's not graceful for sure. You can do something like that.
Oh, right, because the direction, yeah.
Yeah. So once it reaches a new line segment, now it's gonna go. Yeah. Now it finds the new segment here. But the debug readout doesn't change, because that only happens on the original raycast.
Yeah, there are some safety nets involved, basically, that you get corrected to where you need to be.
Yeah, it calculates the new line whenever you reach an endpoint, and that's what this line ref holds the collider 2 points, where the points of world space were at the moment of checking out the line. So that's how it works. That's why it compensates.
Yeah.
Only when you
was wrong because of the raycast being the creator.
Yeah, these points were only created when it was raycasted. Eventually we can change it, but at least for the scope of today's activities, it's not necessary. So we shouldn't be changing it in real time. It doesn't work anyway right now. Let's see when we get back.
Yeah, eventually we'll go to those real-time changes.
Yeah, we'll have to, because like say if this collider is actually physically moving, it will of course have to keep updating that information. So, yeah, so what we want to do now... What's that?
Fix the readout.
What readout?
The line readout to world point A and world point B.
What's wrong with it? Oh, yeah, we're gonna do that first. Yeah, and then so what I'd like to do is try to raycast along the line as far as we're gonna move, and if we do happen to find another collider, that will transition to that. Hopefully, we'll see if that works, and we'll see how we're gonna make it work when we get there. But yeah, you want to see the actual line. So under the debug stuff, I think because we've already got code to do that. Let's see, not local space readout, ground line here. So let's change this to the line ref. So if line ref is not equal to null and line ref is valid, then we'll use the information here. The line color, so point A, not index A, world point A, and world point B. And then line point color A, oh, those are the 2 points, okay. Just change those out. And that might actually be all we need to do. We've already got everything set up here. And so
that works. It'd be nice.
Yeah, so only if line ref exists will it attempt to do that. And I guess we'll find out. Hey, there we go.
Check.
Oh, I accidentally minimized the window actually. Hello! What does gizmos mean? Gizmos is a functionality. Oh, my flux is on. Disable. It's gonna get bright. Yep, here it comes. It's a sunset color mode for your monitor to help you get sleepy, but I don't want to be sleepy right now. So Gizmo is basically like drawing these debug lines and stuff. There's other functionality you can do with them, like making little editor functions, but they don't actually affect the game when it's running. It's only in editor mode, so you can draw lines, see debug stuff. Like using gizmos, I draw this box and I draw the lines and the points and stuff. That's what
they have only appear in scene view.
Yeah, so if we show the game view, which I'm actually off camera here, but you can see he's just walking in what seems to be nothing, because the gizmos. Okay, turn them on here. The gizmos are just like debug options. That's all. So when we're in here and it's talking about gizmos, so this is the coding structure that Unity gives, so I can change the color of the line it's going to draw. I draw a line, draw a player sphere, which is the little circle in the crosshair. That's all that is.
That worked nicely out of the box.
What do you mean?
You just changed a few points and then it works again.
Yeah, because I was thinking about it, I'm like, I already have a data structure for it, I'll just connect it to that, and that's it. Just a little bit. Get more of a view.
Finally we get that function again.
Yeah.
So you see the line update if you go across.
Right. And you'll see that the points, so the orange one is point A, and the pink or purple or whatever it is, point B. You can see that. So, yeah.
We don't need to render a gizmo on the exact center points?
because you see the ray coming out of it, I guess you don't really need to. I mean, you could.
We're doing for Ricky. You added a gizmo on the ray origin.
I could do it. I don't know if we need it yet, but I could do it.
You needed it for Ricky, remember?
For some reason, yeah. I think because the ray wasn't showing right. But here, I think it's okay.
You weren't sure if he was moving, if it was in the right direction.
Yeah.
With the skin with it and everything.
I believe this is because I'm using the direction vector that we worked on.
That does not look right.
Oh, it's because he hasn't moved yet, or he's already moved or something. It's just an update issue. So he's always constantly behind. I think it's just
that's
odd. We can put a origin point on it if you want. Or direction. Oh, you know why? It's because it's taking the center point after he moves, but the visual hasn't updated. That's why you don't see him in the spot where he's moved. It shouldn't be. So what we should do is public vector 2 for ray center point, and we'll store that in debug for ray center point. Where do we set this? So equals transform that position. And it's the end of that. And oh yeah, well, where does this get rendered? I only got one reference. Where does this stuff get rendered from? But Buffalo's? Or no. Alright, I'll just manually look for it. Is it? I think it's this one here. Yeah, so instead of these transformed at positions, we'll put in this raycast center point. So this should be the position of what it was before it moved. And we don't need vector 2 anymore.
Because otherwise the line display is also too long, right?
No, it'll be the right.
True.
Oh yeah, I guess it would be because it's using the wrong point. Well, maybe not.
Because you'd be.
Well, I draw two lines. I draw one that's the actual line. And that's the second one. And the first one is an extended version of it, just so you can see it. Because it's such a short line that's being cast out that you wouldn't see it. So you see the yellow one, that's actually the debug one, just so I know the directionality.
I'm saying the other one would basically be where it's going plus the next update. So it kind of falls away.
So let's pause it. Okay, so yeah, here. That, is that still slightly out?
Weird.
Yeah, this is strange.
The schema issue?
Now it's right. Maybe because that's where I paused it. I don't know. It could just be late updating. The question is from chat says, but you don't need to code every gizmo. They give you the basic tools to draw lines, draw circles, draw, cubes and stuff like that. And you can use those tools to build your gizmo. So like this one renders all the points from the collider.
So Unity itself does the underlying code computing.
Like it allows you to set a color and to like draw these lines and stuff, but in order to draw the shape I had to program it to draw the lines between each point. So
but it's Unity itself that says, you're telling Unity to just draw a line, and Unity figures out how to do it.
Yes, yeah. We just give it 2 points, and it draws the line. Automatically scales it to your scene view and stuff. So, just a helpful little thing. Yeah, I'm not sure if it's just because I paused it on that frame that it didn't like that. Now it seems to be okay. So if I step it through, it's consistently there.
Can gizmos be made visible during actual gameplay runtime?
What do you mean physical?
Visual.
Only in editor. So there is a gizmos button on the game view that allows you to see it, but there are limitations to it. You can't do everything.
You can't like build a game, build the executable, and show the gizmo.
I don't believe so. No, I think gizmos are only compiled into the editor version of the game.
Otherwise, we're seeing a lot of games made out of gizmos.
It's possible. I mean, well, you could easily make something to draw a line on the screen anyway.
Yeah.
Because there are like UI libraries and stuff to do that kind of shit, but you don't need to use the gizmo for that necessarily. Not that it works, but I mean, if it did theoretically work, you still wouldn't need to do that. Yeah. But either way.
So yeah, you were gonna add a circle gizmo on there.
Oh yes. Oh yeah, we can do that. Just to know like where we're
Helps with the
coming from.
stream readout as well.
Yeah. Do we want to put it at the end of the line or the beginning of the line?
The actual center point, just like Ricky did.
Oh, okay. Yeah, that's right.
So you know your origin.
Yeah, that makes sense.
You can see any mismatch.
We'll do it last, so it comes up on top of everything. So, gizmos dot color equals color dot yellow, and gizmos dot draw wire cube wire sphere, and yeah.
Especially in this system, we're aiming to raycast wherever we are going, right?
Essentially,
So
yeah.
Direction changes all the time. You might want to see that.
Do you want to see the last? Sometimes on the stream computer, this MSI task starts running and it starts killing the frame rate. I fixed it. I was seeing high CPU warnings. Do we want to see it before or after the update? Or is that what you're talking about?
No, we want to see where we're heading according to the next update, yeah.
Yeah.
It's displaying the current update with the raycast rendering direction of the next update.
Okay, let's see. Let's do it this way then. Color.
So the center point circle should be on the center point itself always.
We'll make the old update like half transparent, and then we'll draw that, and so that will be this here, and then radius 0.25. Alright, now we'll do 0.5 because it's a big one that we're gonna want to see, and then we'll do gizmos.color equals, or not left of the color, but yellow. And that'll be the full bright version of it, and we'll know that that is the current position. Yeah. And let's see what that looks like. So we should be able to see our last position and our current one. Oh wait, no, I'm sorry. I need to do transform that position for that. That's our current position. Oh, that's fine. Oh god, that's like super big. That's way bigger than I thought it would be. But yeah, it looks like it is working though. Yeah, so you see,
do the big man.
here's the old one, the old position, and then the new one.
Well, they said the last update.
Well, where we started when the update started is the dimmer one, and where the update ended is the brighter one. Although you can't really see it against the.
Change the color, yeah, man.
Yeah. Change it to blue.
Also, change the size to whatever the points are on the line.
Yeah. All right. We've got. What are the... Oh wow, they're tiny. Okay.
Those are reasonable.
Yeah. We want to. Let's do them just a little bit bigger so that they happen to overlap. We know that. We'll do 0.75. Oh, not 5.75. Okay. So that way we know they won't overlap anything and hide anything on us. Where are you? Here he comes. There he is! Oh, that's much better to see. Holy crap. Alright, so we'll pause it. We'll move one step to the left. And yeah, there you go. They're actually kind of hard to see. Since they're so intense. You can see it.
Yeah, it's the center lines are hard to see. Maybe just don't do the semi-transparency.
Yeah, you know what I'm gonna do then? Let me comment that out. And I'm gonna turn this to, is there like a light blue or sky blue? Or cyan? Cyan, yeah. We'll do one cyan and one blue. So one will be sky blue, one will be deep blue. Or we might want to reverse that, perhaps. We want the other one to be darker, but let's just see what it looks like. It looks like it doesn't go over the collider. Oh, it does, just very, very dimly. Very weird.
Yeah, maybe not go with cyan. The dark blue is hard to see.
Yeah, I think they just don't overlap the colliders very well. What if we change
I don't think they do.
Yeah, change the material here. Where is... Oh, you know what? I think it's because we're giving it a Z here. If we chop off the Z, because it could be rendering behind it, because this will take a vector 3, which means it has depth. I bet it was rendering behind the shape. Is the problem.
Could be.
Yeah. Looks like it's. No, it still doesn't go through. Weird. So that makes me wonder: does this guy overlap these? Oh yeah, it kills these line points too. So yeah, it won't go through the object. What I might do then is, where's the material?
But on Ricky, they were doing that just fine.
Because he's a sprite though. This is This is a different kind of thing. Where is his material? Mesh render, transform, blah 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 blah. Here's the material. Where is this located? Or, you know what? Just change it to like, oh shit, I meant. Change it like dark. Maybe that'll help. I don't see any lines at all now. What happened?
Gizmo's finished.
What did I break? How come we don't see lines anymore?
Somehow Gizmo view.
Look, when you minimize this, the gizmos go away. That's what it is. Okay, weird, but yeah, alright, whatever. Alright, we might be able to see it a little better now that it's dark. Yeah, it doesn't really hold up. Well, what I can do is...
Eating. Make it transparent.
Gizmo, or I'm sorry, WizUtils Unity Gizmos draw axis 2D. We'll just do that. we'll combine it. We'll draw the axis over it. Position and the color blue. And let's see if that works. Wait, do I have an option to make it a different size? Oh yeah, the size. Or wait, let's just vector 2.1 times 0. What was our 0.75? Yeah. Let's do that, and I'll put it for the other one too. So I've got some functionality here built in my library. And this is also these WizUtils I actually have on the Patreon. I'm pretty sure that draw axis is part of that. I'll update it if it's not tomorrow, but I think it's updated to the full thing, to the current version. So that's part of some of the Patreon rewards we have. And damn, do they actually come in handy. So whenever I come into a thing and I'm like, I do this all the time, I just make a utility for it in my WizUtil.
Sign.
Oh, yeah, you're right. I do have some. Bad. Because otherwise you'd have to tell it to draw 2 lines and shit, and so I'm just like, screw it. We'll encapsulate the code right in there.
Works?
Yeah. There it is. So, it draws over it. You'll get the lines from the wire cube still in here, but it does draw over it. Oh, you know why? Because that's a radius. So we have to do this times 2 in order to get the full size of it. That's why it's like halfway through. So yeah, where's the cyan one now? Is it not drawing? Or
Can I suggest you make the I think black or something?
make what black?
Because either the cyan doesn't show up, the kicker.
Oh, the
Either
character.
the cyan doesn't render well, or the dark blue doesn't render well.
Oh, here it is. Oh, you know why? Because I was sitting still. If I move them, there you go. And you can see them both. Yeah, so it's working right now. It's working good.
Like now, right now, the dark blue is hard to see.
It is. So let's swap the cyan and the dark blue. So the dark blue will be the old, and the cyan will be the new. I think that would make the most sense. Because we're going to be mostly looking at the cyan anyway. So that's the one we want to stand out to our eyes here. Yeah, that's what better. Oh, I gotta use a controller. There. Yeah, alright, that looks okay. That makes sense. The dimmer one is the old position, and this is the new one. So.
So we traveled that far in a single frame.
We did, yeah. I believe the delta time is a little different when you step it like this. I don't know if it's longer or shorter. I think it might actually be shorter when you do the steps like this. I've had where it didn't look like it was consistently.
So where is the actual ray cost?
The raycast from...
So I don't see that. You see the yellow line.
Yeah, and there's a disparity here too. So I don't know. It should have cast from here though. Let's see, is our display code right? Before center point plus velocity. And then the 4 center point here. So the dark blue is where it should be going from. But oh, you know why? I'm a dummy. I should give this a different color. Because it's red and the line's red, so we can't see it. I'm gonna make it green for a minute.
So you got 2 of the red lines overlapping each other and clipping into the yellow.
Yeah, that's what it was. Because the yellow is drawn first, the red's drawn on top. That's why you couldn't see it. Mystery solved. Let's oop, there you go. Okay, yeah. So it starts here, And the green is actually as far as we cast the ray. And that makes sense. So we see from the old point to the new point. Or we're not actually casting the ray yet, but that's our velocity direction. And then the yellow is just a debug readout to say, hey, we're going in that direction. Because from here, you can't see that green. There's no way to see it. It's just too small. So the yellow just tells us what direction we were casting in.
Yeah, I guess must have anything like an arrowhead.
Not that I'm aware of. I could probably make one. I'll just add one to the utilities at some point.
Yeah, so you could have like an arrowhead at the end of the
yeah, that's
the
a good
yellow
idea.
line.
Yeah, that's a good idea. I think so. I won't do that now. But
so you know what
I'll
that
add
means
after.
in the future.
Yeah, exactly. So you can say array. Yeah, and then we can make a macro function to say draw array, and it'll have the point, the circle point from where it came from, and then the pointer to where it's going. And that'll look cool.
Might help with making them clearly visible on stream.
Right. Yeah, I'll add that. And yeah, again, so that'll force me to update the Patreon version of the WizUtils anyway. So that'll help. Then everybody in TV land can use it, or whatever, Twitch land, YouTube land, wherever the hell you're viewing this. Yeah, that makes sense. So cool. All right, so we got a little more information now. See, I'm running around. The only reason I don't like having this as a dark color is it's hard to see.
Yeah, from afar you can see him pretty well now. You can make him lighter now.
Yeah, I was gonna say maybe make him like a lime green. That's good. Yes.
Yeah, I was thinking what color we don't use. But,
yeah, I know. I was gonna say we're using all colors of the rainbow now because we got all this damn information.
Whatever color is the line itself is, doesn't need to be rendered. Yeah, now you can see that center point from a million miles away.
Yeah, it's bright.
It's nice.
We could make it white too. I didn't think about that. But...
And make it white.
Yeah.
Make the guy white.
Right.
And I know that sounds wrong.
Oh no. Oh no. We'll make him slightly darker. That sounds wrong too. Let's see. He's gonna be gray. He's gonna be gray. He's an alien, alright? Look. He's just an alien. It's kind of rough on the eyes, to be honest.
Right. At least you know how big.
Good one. That's good.
Gray is probably fine.
Yeah, that's okay. That works. I honestly only use green because I've always traditionally used green for the players and debug modes.
Oh, there's actually a white impact marker.
What's that?
White visuals there. There's a white impact marker.
Oh yeah, yeah. That's where he fell onto it originally. It just never
That
clears
has
that
the
day.
contrast.
Yeah. Yeah, you see it in the local space too. Where he landed on the line here.
Can you see it when you're overlapping it?
Probably. Yeah, you can.
But that's good data too, you know, because that's where your raycast has struck.
Right. Yeah. Yeah, absolutely.
Yeah, okay, that's nice.
Yeah.
So what does this mess of circles mean? You look at it close.
Well, that's why I like how they have the crosshair on them, so you can kind of see the middle here. Although when your collider gets too close, those go away. But I'll probably add like a macro thing so that we can get the crosshairs all the time, like we do at the center point.
Yeah, you get a pretty good view of where things are, even if you're overlapping now.
Yeah, you do. So
That's cool.
yeah, because the orange is the current point on the line that you're on. Should change to it changes.
And the green?
The green is just the line points from all the structures, from the structure
Okay.
itself.
So they're everywhere.
Yeah, and I made them the same color as the lines so that you knew that's what they were. And then,
Nice.
yeah, the white is the impact point from when you landed on the structure. The blue is your center point, and yeah, so the orange and the purple are just the points A and B of the current line you're on, and obviously the line you're on is red. So, and I chose red because it contrasts with green. There's no other thought involved. Yeah, so it looks pretty good though. You can kind of clearly see everything now, so we've got a bit more information to work with. All right, so let's say we actually cast the stem right.
Yeah, it's just gonna help us when things go wrong later.
Yeah, absolutely. I'm gonna rotate the poly here so that it's a bit more of a nice angle for us to actually collide with this thing over here. So we'll do it like this. That way we clearly know when this thing's gonna collide.
Yeah. And in the worst case scenario, we pass right through it.
Right. Yeah. And closer.
Move the other one on the other side though.
Oh, I see what you're saying. Yeah. Okay.
Left one.
Yeah. All right. Fair enough. That'll work. Okay.
Yeah.
So
that's a different case scenario.
Yeah. So right now, obviously, it doesn't do anything to the program yet, but
So they're both valleys, but one is
right. One's on the
the
left. One's on the right.
yeah.
Okay. So we don't have the multi-step system in, which we don't need right now. So what we're going to do in words, in plain English, we're going to shoot a ray along the path that we're going to walk. And if we have to compare that to the amount of distance left between where we are and the end of the line, and we have to make sure the ray is the same length of that. So it can't go, let me show the actual.
Yeah, whatever that ray is detecting, it should tell you to snap to the next collider.
Yeah, so see here, let's pretend that the yellow line is the amount of distance we're going to move. Now it goes past the point at the end of this line, so we're going to have to say, hey, we got to scale this back down to here if it happens to exceed how far we're going to go on the line. So that we're not going to snap to a collider that's out in the middle of nowhere here that's not attached. And then once you get to that point, then you transition the line, then you can look down this one instead. And then eventually it'll be like, oh hey, we found something here, you know what I mean? And then it will move us to this point on this collider.
Yeah, right now it detects the collider. It really goes that long.
If it was, yeah.
Yeah, and it would snap to that point in the next frame.
Right.
Instead of overshooting it.
Exactly. And then now we'll be attached to that other collider. So theoretically,
and then we'll be moving across the rectangle now.
Right. Yep. That's the idea. So let's make that happen then.
How do we do that?
Sure.
Place him on the rectangle for a moment.
Over here. You want to see?
And then see. I want to see the directionality on the yellow line. That's correct.
Yeah, it is. And he doesn't know.
Alrighty, then we're set.
I think so. Yeah, I think so. So let's undo the player's position. Make sure it's in the right spot. She looks like it is. Yeah. Okay. All right. So the walking code is a horrible jumbled mess, but we'll try to do what we can with it for now.
As long as it works.
We don't need that. We're already drawing it, but it gives moving higher, moving lower.
I recall the devs for Celeste for saying something similar to like the code's just messy. But it works.
It always is, but I'm working with the assumption that once we get it to work, well, then we'll just clean it up. In the meantime, if we keep cleaning it up every 10 minutes, it's going to take us 3 times as long to get this done.
Yep. That's what I'm saying, as long as it works.
So here, this combined velocity, so I take the walk velocity, which is up here, which if we press left or right, we're adding the walk speed times the time step from our time controller. Time controller is something I made, by the way, so if you're using Unity out there, there's no such thing as a time controller in base Unity. It's just a time management system I developed. But it works basically the same thing as just writing time to delta time. At least in this case right now, it's equivalent to that. So our walk speed times to delta time, and then we store that. And so I changed the direction of this by taking, the walk speed and timing it by the forward direction, which we calculated based on our line reference that we were showing earlier. And so now this is the combined velocity. That's the combined velocity and direction velocity we got. So now we have the direction we can use to shoot the ray, and we've got the amount of velocity that we're trying to move. And then so this is actually a debug value right now. That's
Are we
not
using
fun.
the same ray as before?
We're using that. The data that I was just describing there is what gets you the this red or this green and yellow readout here.
Yeah, no, what I'm saying is,
So this is our
we shot a ray in the beginning, right? Are we reusing that same ray?
no. We're not using that code. We might get out of here, Facebook. You didn't hear that, but I did.
So there's now 2 rays being shot at this point.
No, just one, because when you're falling, that's a different code, so we're not using the falling code. Yeah. So right now we're shooting no rays. We're just showing a theoretical what the ray would look like if we shot it.
Overall code script that you have, there's 2 rays gonna be there.
No, just one. The yellow one is just a debug readout so that you know which way it went.
I mean, the one that happened while falling, and the other one that's happening now.
Oh, yeah. While in those 2 different states, there's two different states.
Shouldn't
of whichever.
they eventually be the same one though?
I don't know. So we'll cross that bridge later. Yeah. It kind of depends. I have a feeling that we're going to have a falling state and a not falling state, and they'll be somewhat mutually exclusive. So yeah, anyway.
Also, one thing I want to mention regarding this whole system is that, we don't actually need to raycast anything to detect how we're moving across our current floor.
Right, that's correct. As long as the thing
And that's
doesn't
actually
move.
really cool.
Yeah, it is, because we preload all the points, and so if you know all the points, you know where all the lines are by default. You can just draw lines between them, and it's just moving between those 2 points on that line. At least for now it
Following.
works. We might need more information later, but right now it's
Yeah.
perfectly fine the way that it is. Because I mean, we're gonna have to detect walls and stuff, so you're still gonna have to be shooting rays left and right to detect walls and shit like that. But
Because basically what we got right now, a normal system would require at least 3 raycasts, right?
I believe so. Yeah.
So that's pretty cool.
Yeah. Alright, we'll fire the ray, I guess, as long as the velocity is not 0. So, if combined velocity, that magnitude is greater than 0, then we'll do the ray.
What if it's a negative now?
Magnitude is always positive. It just means
Okay.
the amount of the vector.
Yeah, getcha.
Yeah. Let's see. Then I guess we'll. What is it? We just use our results or ray results equals physics 2D. Physics 2D. Raycast all. So our origin is going to be. Do we have anything? Oh yeah, we'll just use the transform that position. Okay. So our current center point, and the direction is going to be the floor direction that we've already calculated. And
Don't we have a variable? Factor 2 for the transform the position that we can reuse?
but this is our literal point right now. I'm just
So
using.
you had a
what-
variable for it, right?
Oh, that's a debug variable, though. I don't want to rely on using that.
Ah,
Yeah, that's just
just wondering.
because I start using this, and it's got references outside of debug. Yeah. I mean, eventually these things will go
Yes.
away, but they'll be deleted. So
I
that's,
see.
that's what I mean by it's the code is very sloppy at the moment. Okay, so and then we need our distance, which we're gonna calculate here. Ray distance equals, I guess the velocity magnitude, which, you know what, we're going to put this outside. I don't want to calculate the magnitude twice. It's actually a pretty heavy calculation, from what I understand. So, if the ray distance is going to be greater than 0, then we'll cast the ray. No, we're not going to bother. It's not going to tell us anything anyway. And then the ray distance here. So we do have to scale the ray distance now between. So if moving through this velocity will pass beyond the point that it's at the end of this line segment, we have to shrink our velocity to match the end of it. But if we don't reach it, we don't have to worry about it. Make sense? We were doing this by using move boards, but we're actually going to remove these after.
I have a question though.
Yes.
You just made the float ray distance.
Yeah.
You made a new float. So what is the debug line actually using for its ray distance?
Oh, the debug line takes 2 points. So it takes the point where it came from and the point where it ends up, so it doesn't have a distance. The line is just drawn between 2 points. Where the ray,
We can confirm.
give it a point of origin and a distance. And it
We can confirm that it's correct to what this is.
because it's using combined velocity, or no, this velocity thing here, which is set to combined velocity. So it's saying we're going to take the center point plus the combined velocity is going to give you the point that you would end up on, and that's what that line's being drawn from.
Yeah, so as long as it's correct.
It is, and you can see it. You know it's correct because file a second. When we move, you know it's correct because our old position is where the line starts, and our new position is where the green line ends. So you know that it is correct. We did travel that far.
Yeah. Just as long as what we're shooting is the same as that. Yeah.
Yes. And so what we need to do now is to say if that's going to go over the end of the line segment, we need to restrict that back down. So that is, let's see, how are we going to do this? Depends, I guess, on which way we're moving, doesn't it?
Should you do that after the race constant?
No, you don't want to cast the ray farther than you're going to actually move. So we need to know.
Oh, you're correcting the ray distance.
Right.
Like that.
Yeah.
So you're doing it before the ray shot. Okay, I get you.
Yeah, if we're moving higher, then we need to calculate the float. Distance.
But we only
to
know how
line
far
and-
we can go once we hit something.
No. Well, I mean that's a different part of it, but we don't want to shoot past the end of the line because it will be
Oh, that's the first one, yeah.
right. We will be
Same
potentially seeing colliders off that are not even on the line, and then snapping to something that's farther than the line ending. So we want vectors.
Yeah, I was concerned with the
Distance
I was
between
concerned with the next collider.
yeah. This is between where we are and where we will end up eventually. So then, if the distance to the end is less than the ray distance, then we now need to set ray distance to distance to the end. So we restrict it so that it cannot exceed that if it happens to go over that. So this would be ray is greater than to the end of the line. Now ray ceases now. And so we also have to do this. If we're moving lower, and by lower we mean from the points in a structure, you know, they're like point 1, 2, 3, 4, 5, 6. So going from 4 to 5 is higher, from 5 to 4 is lower. That's all we mean by that. It's a little confusing, but so then we need lower points. It has nothing to do with their actual XY position. Just to make that clear.
Just the indexes.
Yeah, just the indexing. And indexing, if you don't know, means just a series of data. So if there's like 5 points, index 0 is point 1, index 1 is point 2, index 2 is point, or 3 is point, or slot 2. You get the idea. So if you have 5 points, then you have 0 through 4. The indexing is 0 through 4.
Yeah, the order of those points on the collider are not necessarily the same in world space.
Yeah. So that's why we use the local space.
That's why we had to do some fixes when we did the negative scaling.
Oh yeah, we had to reverse some shit too for that. That was a pain. I mean,
because the index just starts flipping around all of a sudden.
Yeah, I can't imagine a point that we would ever actually do that, but just in case it ever happens, we wanted to make sure that it could handle that situation. Okay.
If someone wants to flip the collider or something.
Yeah. So now
the collider just went Paper Mario, right?
What's that?
The collider just went Paper Mario.
Oh yeah, where it's 2D and it just rotates. Yeah, at that point, if it actually ever does get to a scale of 0, I think it's just completely untouchable anyway. So I'm not even sure under what condition you would want to flip it like that, but whatever. If it does, it can do that now. So we've already covered that base. I don't know why it would ever do that, but if it ever does, it wasn't too big a deal to compensate for.
You pull it up, so you pull the inside out like a shirt.
Yeah, pretty much. Okay, so now we get our Bray results, and we want to now. Yeah, we want to go through them. So for integer Bray result ID, I would say result ID. You know what it is. Equals 0. Result ID is less than Bray results dot length. There's a series of data here, and result ID plus plus is our simple for loop. So because I'm assuming it's going to capture this, if the collider, result ID, if the collider is already what we're standing on, so line ref dot collider, then we don't bother doing anything with it. We're going to continue through the results. I have a feeling that it is actually going to capture that. I wonder if this Bray results is if this happens to be a structure we can look at. Maybe we can actually see the data in the inspector. Let me add a value for that. See what data type this is. Braycast hit 2D. Cast hit 2D. Array. Let's actually make a debug value of that and see what we actually get from it. So we'll say public raycast 2D 4 mode raycast results.
Explain something for me.
Yes.
Why are your initializations far down?
Oh, because these are all under debug. Oh yeah, I should say debug. Yeah.
I'm ready to see it now. Yeah.
I kind of organize them that way, and so that when you put a header in, you can see that in the inspector. It'll say debug, and then all the debug stuff will be under it. That way it's kind of organized in a way. Okay, so where are we here? Yeah, we're right here. So here's our.
I was thinking the
debug.
that if then code there doesn't look optimized properly.
Oh,
Like ray distance equals distance to line ends being set twice like that.
oh, that's
It
these.
looks so unoptimized, man.
It's not though, because you're only gonna go to one of these.
Yeah, I mean, there's a
You can use the same name as long as it's in enclosed scopes like that.
just the fact that you end with the same line twice in both sections.
Essentially, yeah.
Fucks the hell out of me.
Oh, I don't know how else to do it. It's just what it is. Sometimes it just looks weird. Okay, so if we did hit something, then
Like I'm saying, if distance to line end is smaller than ray distance, it could be outside of the if. Should it?
you could put
Well,
this.
fuck up.
You could put this outside, but you need higher point and lower point. That's why they needed to be different.
I mean, the next if statement.
Which one? This one.
The if distance to line ends is smaller than ray distance, it can be outside of the if moving higher, if moving lower section.
Oh, okay. I see what you mean. Yeah, because that never. Well, then we have to move this outside. Yeah, but that's fine. There should be an issue with that. I see what you're saying. I see what you're saying. I'm picking up what you're putting down. As the kids like to say. I don't know. Does anybody say that anymore?
I learned something from my 1 week of C#.
Yeah. Oh, now it's pissed off. We gotta set it twice now. So we have to set it to 0, and then we set it through the. We don't need to use brackets for curly braces. I always get in trouble. I call them brackets, and AJ yells at me. I think brackets are these, and then curly braces are these. Like I get yelled at when I don't call them the right thing.
Yeah, the character from Cave Story is not called bracket.
Yeah, I know it's curly brace. Yeah, which is actually a direct reference to programming for anybody who don't know. Okay.
Oh, it reads a lot nicer now, right?
I think so, yeah. Yeah, I guess that makes sense. I just didn't pick up on the fact that that was that way. Like, again, the code's a mess. We will clean up all that kind of shit later anyway. But yeah, it doesn't hurt to do it now. So this
Let's calculate the right distance anyway.
Yeah. So there. Okay. And then if the distance is 0, then I mean, it is what it is.
Yeah, it won't reach there.
Yeah. Okay, so array results. We do cast array here. And we set the debug results here. And actually, you know what? I want to see, without actually letting it do anything further, I want to see if that shows up in the inspector here.
Yeah, remember, Mark, move the correct thing.
It doesn't look like it.
Rotating and scaling.
Doesn't look like it's actually showing. Let's see, where is it? Debug for. So that's right under walk velocity? Yeah, it doesn't show anything about it. I wonder if we can make it show, though. No, but yeah, if this is not a if this is not a serializable thing, maybe we have to force it to serialize field. It's possible, but if it's not serializable already, then it won't show up in the inspector like that. No, it still doesn't show up. That sucks. I would like to see that. I'm trying to think if there's any quick and dirty way we can force it to do that. Like if we do a public class, I don't know, derp inherited from Raycast, and then say that this is serializable. I don't know if it will. What's it? Cannot derive from A sealed type. Is this a struct? Oh, it's a struct. Shit. Wait, hold on. How about struct? We can't derive. Oh, yeah, you can't derive from structs. Yeah, we're hosed. We can't do it. So that sucks. We'd have to make our own thing to contain that amount of data. We'd have to make a custom thing, but that's going to take a while, so I'm not going to bother. What we
Would be cool.
Yeah, what we can do, let me do a list of Collider 2D, and I'm going to say colliders, equals new list, and I'm just going to copy all the colliders into the list, so before it decides to continue, we're going to add the collider from the results, and then we can
I would imagine Ray results might be complicated to render as well, because they could be seeing 0 things, they could be seeing many things.
No, it should be capable of that. They just don't want us to use it, apparently. For whatever reason, they don't want you to look at it that way. Oh, wait, hold on. We can see it in debug mode, though, can't we? No, we can't. No, if it's not serializable, it's not serializable. Hold on. Let's double check. I'm gonna put that back. So public raycast hit 2D debug for raycast results. Let's go back here. I don't know if the debug view will let us view it or not. We'll see. If it does, it does. If it doesn't, then whatever. I'm not going to worry about it too much. We'll at least be able to see the colliders. I really just want to know if it's going to show the colliders or not. Bonk. And actually doesn't see anything currently. Oh, because our walk velocity is not there. But okay, so
walking.
Yeah, let's look. No, it still doesn't show you. Even in debug mode, it still doesn't show you those raycast hits. That's funny. Yeah, all right. So let's walk and see what happens. Frame advance. It does. It found a box. How did it find a box? What? Why did it find a box? Oh, it itself. It's the player itself. You're right. Okay, so we need another thing to say that. Yeah. Welcome to programming.
It's gonna snap the player, the player to the player.
Yeah. Collision box. Okay. Yeah, it's just a collider.
So what? We gotta exclude hit 0 now?
Well, we just exclude them based on what they are. So if they're one of these two things, actually, I'll condense this down. Because we're only looking for different ones, so...
I was gonna ask this earlier, but this system doesn't have a skin width concept in place.
Right, I don't know if we're gonna need that or not. I guess we'll determine that as we go along. Only looking for different colliders other than the one we're standing on.
It won't, because you'll be changing your origin point and everything.
I don't know.
Because of the angle rotation, you know? Because you want to always pass through the exact center point at the edge of the collider.
If we do the skin width, though, then our center point's actually going to be like inside too, so I don't know if that will work.
Yeah, it's going to move. It's going to move inside.
Yeah.
It's going to be really weird.
Yeah, that's why I didn't bother putting that into this rendition of it, because if we don't need it, then that would be great.
An exclusion system.
Yeah, if we don't need it, that would be great.
Cool.
Whoa.
There's something interesting about this. Not sure if you realize this.
What?
Mark?
What's that?
Cool. Stop this. It detected the polycollider that we're on.
It did, yeah. That's what I was looking for. That's why I set up this little debug readout, because that's what I wanted to see whether or not it would actually detect it. So we could update the points at that point.
Yeah, we're so properly on it that we're seeing our own collider.
Mm-hmm. Yeah. So we're very accurately there.
Yeah.
Okay, there we go. So yeah, collision box.
And this is an infinitely thin line in infinite space,
Mm-hmm.
isn't it?
Yeah.
It's crazy.
Yeah, it is. It means we're exactly on it, or at least close enough to detect the ray. I'll be honest, I'm actually not really sure the math behind a raycast. I really don't know how that works. I know that it developed the idea, from what I understand, but that's all I know about it. So I guess John Carmack made it. I don't know.
But basically, we're so close that we're seeing it. That's so cool.
Yeah, pretty much. So,
You didn't expect that, right?
I wasn't sure. I honestly was not 100% sure. Now we're not moving.
So go
though.
across.
We're not moving, so this might change if we start moving.
Yeah, go across it. I want to see what happens.
Oh, I can't. We disabled. This gutted the movement code.
Oh.
So that's our next step. We have to move now, based on this ray
Oh, okay.
distance. So
Did you come it out?
I had to because it's just not going to work the same way anymore.
Okay.
So now we need to say if we did bump into something. So at this point, we have bumped into a new collider. So the ray distance is going to be equal to the ray result ID and distance. So we're scaling our distance down for the fact that we ran into something else. So we need to now transition to a new collider. And so we're going to have a flag here that says bool transitioned to new collider. And we'll say it's false normally.
It doesn't. Does it look type correcting now?
Yeah, I'll just say transition. Is that right?
No way, it's wrong. Yeah, that looks better.
That looks better? Okay. Yeah, so if we transition if we transition to a new collider, we're going to do something here. And if not, then we have to do the code here to keep ourselves on the line. So this basically just checks if we've reached our destination on the line we were on. However, this is completely inapplicable if we've changed to a new collider.
Yeah.
And so if we've gotten this far, this is true now. Assuming that it's an actual solid, but we're just taking out the collider at this point. That's just not ours. So we may have to make this a little more nuanced later, but for right now it's fine. So ray distance, results, distance. So this is going to affect how far we move. Yeah, so we're going to take... To actually move here, we're going to need to make a new velocity. Move velocity equals 4 direction times ray distance. And then transform that position equals transform that position plus move velocity. And that actually move character. It's probably wants vector 3. So there we go. I mean, let's just make this a vector 3. It's fine. It doesn't really matter. The 4 directions already a vector 2, and we're not dealing with C because it's 2D. Yeah. So then this actually does the move. And then now that we have... Yeah, well, if it's...
Or only when it's detecting the end point.
No, it's all the time. Let's see. If ray distance... Yeah, we'll put this in here. So if ray distance is greater than 0, otherwise we don't care because we're not moving. So if ray distance is greater than 0, then we actually do the move. And then after we check, did we transition to a new collider? And we're going to do shit here if we did. maybe, or that could just be the exclusionary for this. If we didn't, this one, then let me write here that we're still on the same line as when we started moving. And so now we're checking to see if our position is at the end of the point or not. If it is at the end of the point, then we transition to the next line in that collider structure. Only if we're still on. But if we transition, we don't do that. So we do this instead, whatever that happens to be. We're getting to that now. So transitioned to the new collider is true at this point if we have bumped into something other than ourselves and what we're currently standing on. So line ref. So let's see, how did we do this initially? Line ref equals new line ref. So up, yeah, so this is in our falling code. Another mess. This is what we did here.
What falling code?
Yeah, I know, really. The stuff we weren't looking at before because it wasn't relevant, now it is. So we do need a new line reference. We need to know what point on the line that we ended up colliding with. Which actually means we're probably going to have to copy some of this.
Something went horribly wrong. You didn't find the line.
Yeah! Something went horribly wrong. Where is it? Yeah. I think
falling into space now.
At the point that this was actually being... Oh yeah, this is... Yeah, because the ray, at this point, the ray has hit something. So if you somehow couldn't find the line, even though you actually collided with something, then yeah, something went horribly wrong. That's why I put that there. I don't ever expect to see it, but it will stand out if it does show up. I'll be like, what the hell's that? I'm like, oh yeah, okay. That's not...
Horribly wrong.
Oh yeah, horrible wrong. Something went horrible wrong. Horrible wrong. Welcome to Game Dev Tips from Spelling.
Both times horribly.
Oh, did I do something?
You wrote it twice. One is horrible, the other
horribly.
horribly.
I must have copy pasted it. Yeah. We might have to use the same kind of code because we do have to check line results. We basically have to fall onto it all over again. Yeah. Damn. Okay, this is a lot of shit too.
You're the master of copy paste.
Yeah, I was gonna say it's gonna end up being something like that. Jesus Christ. All right. Region. Transition to next collider.
Yes, Larry, you're absolutely right.
What?
Larry's absolutely right.
Yeah, what a horrible night to have a curse. What a horrible night to have a fucking giant setback. I don't know. I don't want to call it a setback, but...
You said a horribly night.
Oh, a horribly night. Yeah, a horribly night. I was gonna say, we are actually not far off from the end of the stream at this point, unfortunately. I don't know if we'll get through all of this. At least we explained what's going on. Hopefully that was...
Just copy and paste it, man.
Oh yeah, but it's not just gonna work like that. Actually, it might. I'm thinking about it. If it's inside another ray...
Fix it off stream.
Oh yeah, it's inside another ray casting like thing here, so it might, maybe it will. I don't know. All right, whatever. Okay. Fuck it. And move distance. Okay. So apparently there's a variable move distance. Yeah, up here. All right, we might have to make that. I mean, we kind of have one already, but. Alright. It doesn't know what the debug data is, and it expects this to be called results, that's fine. We can change that to results. Yeah, so rename that to results. So we need the move distance. Their raid distance. Which, I don't know, move distance, whatever. We'll call it move distance, that makes it happy. Or it doesn't. Move distance is not existing. Oh, because I didn't spell it right. Distance. Okay, it's happy with that. I think only the debug data is wrong. Well, I'd like to have it because it will tell us all the information that we get from the initial raycast. So it's only a matter of making it. Where is the update? Where's the update? Oh shit! There's like other stuff. No, we got all this. I think. Yeah, here it is. So we gotta clear it and then add it back in. You know what? Fuck that. We're putting it on the outside. Fuck that. Put it on the outside so it'll be there all the time anyway. And so now this should be happy. Yay! I don't see any errors. If this works, I'm gonna shit. But it's literally the same kind of code, so it should be pretty. It should be pretty solid. I know, we'll find out. We'll see what happens. Well, no, we fucked up. Something went wrong, but there's a whole bunch of. Something went horribly wrong, and you didn't find any line. We finally see it. Oh my god. Well, something did go horribly fucking wrong. That's for sure. Alright, let's see what's actually going on here. Oh, it killed our points too, because we didn't. They weren't getting updated, so we can't see it unless we put it on Polygon. That's fine. Whatever. Actually, maybe I can fix that.
What a horribly not have cursed.
Yeah, pretty much. Yeah, so the code that checks for the points here, we need to... Where are they here? Get local points. Local points is gotten from here. And that happens before... No, that happens in that part. Okay. Yeah, what we need to do is just make sure we are in the walking code that if we do collide with the with the thing that we're already colliding with, I have to separate these back again, basically. Then I'll tell it to actually fill those points in. World points is where now? Where does that fit there? We have to look at. Okay, we gotta look at the code here. This is the following code. So world points is a vector 2. Okay, here. This is what I need to copy actually.
You didn't listen to Bob, did you?
What's that?
You didn't listen to Bob, did you?
Who's Bob? What? What's Bob?
My C# instructor.
Oh, Microsoft Bob. Yeah, Microsoft Bob. That was actually a pretty good tutorial, the one that I sent you. I was actually, I was listening to it, and I'm like, yeah, this is pretty legit. All right, and so that's why I sent it your way. Yeah,
telling me.
If you guys want to work,
paste the enemy.
Yeah. It is. It absolutely is, but it's a necessary evil. Microsoft C#. Let's say if you want to learn Microsoft C#, like just go to, what is it? Where is it? Tutorials? That's docs. Is that it? Where's Microsoft, Bob? Is it this guy?
There he is.
Yeah.
Second one.
I'm just because there's one from Microsoft themselves.
Yeah, but that's it though.
Because this is
the beginner one.
Oh, this one right here. Is this it? Yeah. This is from Microsoft. Yeah. So go. Is this
Hello, I'm Bill Wagner.
No, Bob Tabor.
Welcome to an introduction to C#.
Is that who this guy is or no?
I think C#
No, it don't look like him.
No.
Bob's got glasses.
Another one.
Time to learn it.
Maybe this is a new
Go back.
introduction.
Especially
Yeah.
designed for the-
Yeah, but I'm just saying that it's not from Microsoft, so that might not have
Yeah,
all the
but-
videos there. That's what I mean.
But that's him.
That's him,
him,
though.
I think.
It looks like the same guy. I don't know.
Yeah, it is. It is.
Well, somewhere is, let's see. Let's put Bob. Put Bob in. Fundamentals, absolute beginner. Here we go. Is that what this is? Oh, shit.
Yeah, that's what it is.
Is this it? Or no? This is something else.
Yeah.
Oh yeah, this is it. This is it. Yeah, okay. So just search Microsoft C# tutorials Bob, and you'll find it. C# fundamentals for absolute beginners. This is
That's
actually
my 1 week of C#.
yeah. This is actually a really great introduction. So if anybody out there wants to get into C#, this was actually really great. And then I gave it to Tim, and a week later he's like making programs. So there you go. I mean, now Tim's a smart boy, so you know, meet
I
your
never actually
expectations.
finished though.
No, you didn't. Oh, slacker, get back on it.
I'm like, I'm 4 lessons short or something. Like the last few I never did.
Yeah, it takes you through everything. Installing Visual Studio, creating little programs.
It's like me never watching End of the Walls.
Yeah. You better finish that. He fell asleep halfway through Gundam Wing Endless Waltz. Like, what the fuck? Get back on that. Yeah, but this
I had
is
a long
great
day,
tutorial. Yeah, you had a long day. We all got long days, listen. Okay, so I'm just gonna
Let's get back to it.
set the debug here, and then we're gonna still do the continue to continue through the loop. So yeah, so we will just continue there, but we want to reload
Backslash?
these points.
Backslash?
Where? Oh, I'm sorry. Yeah, I hit it by accident. So now this should continue to draw the shape.
Something went horribly wrong.
Yeah, I think that's because he exceeded the line there. Yeah, okay, so it's still... Oh god, I can't go right. Going left goes right, and right goes left, and... Okay. I think that's because...
Hey, you detected the new one though.
I
You
did.
latched onto it.
I did eventually. Completely fucked up.
Your
yeah.
save point detection, it was messing up.
Okay, so I think we don't have directionality here, so we need to continue to apply this with the higher lower. So yeah. So this is moving towards that. Man, how are we gonna do this then? Do we still want to use the move towards if we're still in the same collider? I think we're gonna have to.
Oh, that's why I'm breaking.
Yeah, because we're not moving towards anymore. We shouldn't have to do that though.
Well, that explains why your movement code just broke.
Kind
You
of.
turn that off.
Well, not necessarily though. Let's see. So let's collapse this. So this move velocity should be forward direction times the move distance. Transform position. Let's see. Yeah, so direction, normalized direction. Forward direction, how do we calculate this? Oh, from that tangent shit. From the 4 angle 2.
It's complicated.
Well, here's the thing, we're not... What I want to know is, how did I know which way to draw the ray? And
When I wasn't here.
Yeah, I was gonna say. Let's see. Let's look at the code that actually draws the ray here. So I did 4 direction plus the velocity, which ended up being the combined velocity. So this is the 4 direction times the walk velocity x. This combined velocity. Then we got the magnitude of that and put it into here. We kind of went backwards because honestly, for walk velocity, x is really our move distance. We don't even need to calculate the magnitude of that anymore because we're not actually combining anything else into it.
You know, right now.
But this could be a negative number too, and that's not good. So that's why we did the magnitude. But then we lost our sign. We lost our sign on here. So what I can do when we do this,
The direction has a sign though.
yeah. So I can do times math f dot sign of walk velocity x, and that should give us what we need.
Maybe.
I think that'll do it. We shouldn't be using the move towards. Yeah, that
No
works.
wonder flip
That
that.
It works.
Yeah, now see you can travel across.
Uh,
Why is it flipping out in terms of is it drawing 2 debug ladders?
well, it's just gotta have poly on. If you select the solid, it'll draw it. But I haven't had this one. Okay, so we're reaching the end here. And apparently we're
Service says.
we're broken. Oh, we broke through somehow. That's not good. Why is
Yeah,
it?
that's what I was doing before too though.
Yeah,
basically-
that's not good.
It can get to the point, but after the point it's like it to break out, staying where it is.
Alright, I'm gonna make one change in where we're going to actually remove the distance check. I want it to shoot a 0 ray, just so it gets these points again, and it's not freaking out over and over. I did notice that sometimes it didn't find the collider. So sometimes it's not actually on the line. Like right now, it's actually not detecting the line under it, I believe. But now it is. So you were saying how close are we onto the actual line? Apparently we can be off of it.
Yeah. But for the most part, we are pretty close.
Yeah.
Across the boundary mark.
Well, here's the thing. I think that's why we're passing this. Because we're slightly off the line enough where we're able to
But we
not
shouldn't be doing
detect
that by raycast though.
that we're not detecting. Yeah, that's what I'm thinking. That's what I'm thinking. A breakthrough. Yeah, thanks, Larry. A breakthrough. I think you're right. I think that we shouldn't be doing it this way. But what we can do...
Like the raycast is only for new colliders, not the same one.
Right. So what we want to do here... instead of this move, we're going to use the move distance, but we're not going to actually move. Come on. KC. There we go. We're going to use that here, and we're actually going to do what we did last time.
Or
Yeah,
in
so-
position or not.
Yeah, if we transitioned to a new collider, then we do want to do this. You're right. Absolutely.
That's why I was questioning it before.
Yeah. Because we need to get to the point where we moved. But if we didn't do that, actually, we have a bracket for that already here. So, ta-da. Yeah, and if we didn't do that, I'll put that bracket back. Don't want to react with that. If we didn't do that, now we have to use this move board. And so instead of doing this, we're going to use the move distance. And we'll copy this to higher point. Yeah. And then we check to see if we go to the next line. That'll be the safest way to do this. So move towards this at the distance. Because we've already calculated our time factor, I think, into all this shit. I think. Yeah, because we're doing walk velocity X. So that's already been time scaled. So this should be okay. If he starts walking really fast, we'll know I screwed something up. No, he looks okay. He cannot walk back to the right? That's weird.
Did you only make a change on move higher instead of move lower?
Oh, you're right. You're right. No, I made it so that it actually did it on both. So, move higher.
Yeah, there was
Only
something
had
you
one.
copy and you changed.
Yeah.
You changed and you only did it to move higher.
It was out here. So it would move, regardless if it was move higher or lower, it would move higher, and then it wouldn't do anything and move higher, but then it would move higher,
Yeah, so move this
and then
to
move
that.
lower, so it would counteract the move. And that's why it looks like it did move, because it moved left and then right again. Or higher and lower again. Yeah. Okay, we're good now. Okay, so our original functionality is back. Thank God. And now it flips the fuck out, so there's that. I think because it's
Hey,
putting
you
us...
landed on the new collider though.
It did, but it's also re-landing back onto the old one at the same time, because we haven't moved anywhere since then. So now it's
Yeah, but
detecting...
you're so close.
Yeah.
It's still in there.
It's detecting back and forth. Now it's just going back and forth between them every frame. So you can see it's got that
So you need some
focus.
sort of previous collider statement.
I think? I don't know.
We were previously on that one. Don't ignore that one now. For the one update, ignore it.
For the one update. Yeah, I don't know if that's the right way to go.
Yeah.
I'm trying to think for a second to see what should we actually do here.
Hey, yeah, we made progress. We actually did land on it.
Oh, absolutely, yeah. Yeah, we're doing pretty good actually right now. As busted as it looks. Oh, Slash. Yeah, Slash is great, isn't it? Oh, you can't hear the music then. The player can.
I could, but I'd hear myself.
We've got, let's see, 3, 3, 2, 3. Yeah. 9. We got about 15 minutes left.
Sounds good.
Yeah.
Music.
Oh, that's right. You can hear it through the Twitch. You can view it. If you
Well,
want.
like I said, I would hear myself if I do.
Yeah, I was gonna say yeah.
And you double is really confusing.
Yeah. Yeah, that sucks. When I was watching AJ, when I was participating in AJ's stream when he was on this channel playing Resident Evil 4, I couldn't hear the game audio. It's the same reason I had to just block it out. I couldn't fucking hear it because I'd be hearing myself and
There's a funny situation with Sophie when she listens to these streams and I'm on them. She can't tell whether it's a stream or me talking in reality.
that's funny. Yeah, I have that too. I think I was actually reviewing the stream when we were on Discord, and I was like, "Wait, what? What'd you say?" And you're like, "I didn't say anything." I'm like, "Oh shit," because I'm reviewing the stream, and it just sounds like you. I'm trying to think now. So, I guess for now, we could say what was the last Collider. But then the update's gonna end, and then it's just gonna do it again.
Well, until you flip direction, I think would be the best case scenario.
Or, yeah, until you've actually moved again.
Until you flipped toward it again. I say, but then again, if he starts to move something on the other side, you go through it.
Oh, let's see.
Could be a time-based tolerance.
You know what? You know what'll actually will fix it? Is because we're raycasting when we're standing still. So if I reactivate the code that only casts, yeah, where is this? Hold on. These points are getting wiped out eventually. Let me just end the code that does that. Where's the code for that? So these collider points, I think, are getting wiped out at some point. They're getting reset. World points. Set here to world points. Is this the falling? No, this is the falling code. How are these people getting wiped out for some reason? Where are they getting reset? Collider, GM. Okay, that's the falling code. Then this is the transition to new collider code. I don't see where they're getting wiped out. I don't know why they're getting wiped out and they're not drawing. Well, let's look at the draw code. Oh, it's because they don't draw? Yeah, they don't draw unless there's data to display here. That's why. Because they're part of this data object. Alright, I'm not going to worry about them. They can just go to help now. We'll only see it when we're moving, and you know what? That's fine.
Lots of
Whatever.
lots of biblical references in the stream.
Yeah. It can go to hell. Okay, so we're not going to worry about that, and we're going to reinstate. Collapse that for now. Yeah, we're going to reinstate. If there's no move distance, then we're not going to do anything. We're just going to sit on our ass and do nothing. Yeah, so it'll only draw it when we move. That's fine. Yeah. But I think that actually no, it doesn't fix the problem. Huh? That's weird.
I'll reverse the code.
Oh, you know why? Here's why. We're stuck at this intersection now, but when we move, we see this collider at 0 distance, so it prevents us from moving, and it's just doing that back and forth. You know what I mean? Like, even if we...
Yeah, I know.
Yeah, okay. Okay, so that wasn't the problem.
I knew it already.
Alright, I was not thinking of the correct thing here then.
Yeah, undo that.
No, we still want to see it every frame. It's
Well,
not going to matter either way.
You want to see the purple ladder?
Yeah, that's what I did. I commented out things that prevented it.
Sure, if we could just either one update or a certain time span, ignore where it came from.
Well, we can't do it by update because as soon as you let go, like it's still updating when you let go, so it's gonna do this anyway. But I don't know because
Flip up.
maybe we can do it after it actually moves. So as long as move distance is 0, then it will not clear the last
The kinetic energy redirection would help here a lot, but even then, there's the one fringe case where you're exactly hitting the spot.
Yeah, and that's what we have right now because we don't have the segmented update code. But I think I think we can get something here. So public collider 2D last what do we call it? 4? Yeah, last 4, whatever. Collider. So right now it's going to equal null. It's nothing. So we just don't set it to anything. So what we'll do here, two things. Is this the fall code or is this the long code? That's the fall code. Collapse that. 2 things. So, one, we're going to add an exclusion here. So that if that thing actually exists, and if it does, we're going to check it against this. Then we continue. We don't bother with it. And so, what we're going to do here is... Give this... Oh, wait. Is that right? Yeah. Hey! Oh, shit! Zombie! Aw, Zombie subscribed. That's right, because it's August. Oh, shit, it's August. Fuck, time's flying. That's not good. Zombie, thank you very much. Almost a year, yeah. Another year. Yeah, you're in 23 months. So yeah, 12 times.
You know what it means, right?
What?
You gotta give him a game where he can kill zombies.
A game where he kills zombies? Oh yeah, the mansion game. Well, we got zombies. We got zombies in the game. Where are they? Here they are. That's the old zombie. Where's the new zombie? Here's the new zombie.
Kill him.
Another one. Yeah, almost 2 years. Holy shit. Crazy. Thank you very much. A Metroidvania zombie game. Yeah, well, I mean, the mansion game is going to end up being that way, so, I mean, kind of Metroidvania, sort of, with a twist-ish. Yeah, we'll see. We'll see what people want to describe it as. A kind of, sort of Metroidvania.
Everything's in Metroidvania nowadays.
Yeah, I know, really, isn't it? There's like 10 of them every week now. Okay, so the second part of this code is that
Well,
when...
even when it isn't a Metroidvania, it will be underestimated. Even when it isn't a Metroidvania, it will be called a Metroidvania.
Yeah.
And the hardcore guys will be like, no, it's not a Metroidvania.
Yeah. It's a buzzword now, unfortunately.
It happens all the time.
So, if move distance is equal to 0, or not equal to 0, then we will clear this to null. Only if we have moved will we clear the last 4 collider. But if we haven't moved yet, we went nowhere, then we won't clear it. And so once we get to this point, to transition, we have to set this last collider to equal line ref dot collider. So we store it here. We ignore it here if it's already set. If it's not set, then we don't do anything there. And only reset it once we move. So it should ignore it only in that one instance. Now this...
Sounds sensible.
Yeah. I have a feeling that eventually this is not going to be good enough, but at least for now, it gets us somewhere. Weird. No, that didn't quite work out.
It's keeping you on the old one.
Yeah, it actually
Also,
moved
you were
us.
inside the floor.
Yeah, it moved us 1 unit into here along the old line. And it still thinks that the line ref is this. So, okay, alright. That's something to go on. Move distance. Here, okay. Transition, yes.
Kind of feels like it's treating the new one like the old one.
Yeah, I think it's not updating the line ref. Is what's going on. For some reason. What did we get any errors when we did this? Oh, we did. Something went horribly wrong. I love it. Somehow it didn't find a line, even though we found a structure. Oh,
Amazing.
Jesus. I don't know how the fuck it even got to that point, but alright, let's take a look. I guess that's why it didn't update line ref. Yeah, alright. Let's time. Let's
What
step
did that
it
mean
down.
we were inside of it?
Oh yeah, you're right. That does mean we're inside of it. Okay, so boom, we hit a new collider. But look at it's still showing this is going to be our next move. So now that we hit a collider, let's stop and let it calibrate and see what happens. We're going to move right again. Yeah, it went inside, and now it's busted. Huh.
That shows you everything you need to know.
Oh. Got the time's up sound. So I guess that's as far as we're going for now. Yeah, alright, well, we've definitely got some issues to fix anyway, so kinda is what it is. You know, I'm just gonna look quick to see what exactly is going on here. There's gonna be a lot.
It's flip-flop. It was using the old line reference on the new line.
It is, but I'm not
And then
yeah,
flipping back.
yeah,
But it stays on the old line for just that second,
right,
and then it's like, oh, we're now back on the old line.
yeah.
The next moment.
For some reason. Okay, so we
Because
hit. Boom.
the problem is the directionality update here.
Yeah, line
In this
graph,
frame, it's still pointing down, and that's the problem.
it shows solid. So the line graph is actually right in this instance.
Yeah, but your array is not updated. Your array is pointing
Right,
down into the floor.
you're right.
So it's following the line it was on, and in that second, once that movement is made, it flips back to the other line.
So four
Because
direction.
now the old line is the rectangle.
Four angle. Maybe four angle's not getting updated? What's four angle say? Four angle is...
So the next frame you
no,
get
four
moved to the
angle-
floor, and
Four
now you
angle 0.
next it's a raycast where the problem is. The raycast is old.
Maybe. Let's see. Let's step through it quick. We got a few minutes to do. I'm gonna restart it here. Okay, so I've got it. Yeah, I've got the
Because that
compiler.
that raycast is making you follow the old line, and then you've moved, and therefore you're back on your line.
Can I get one more here before it hits? Yeah, okay. Now I'm gonna put the stopper in on the compiler. And we're gonna move forward. Okay. And we're gonna see it moved forward. Floor angle is still 52. Now it should only be moving as far as it needs to move. We did determine if we're moving higher or lower, so this should take effect. Let's see what it changes here. Moving higher is false, so it's going to be moving lower. The distance to the end is 0. I guess we're already at the end. That's interesting. Oh wait, no, it hasn't
You
calculated.
may
there.
need to
Yeah, it hasn't calculated.
recalculate your array direction.
So there's a 1.0. Our move distance is 0. Hey, what? Oh, that can't be right. Distance to the end of the line is 1.0. There's not that much space left, is there? No, no way. There's no way that's a whole unity unit. Something might be wrong here. Distance between our center point to the lower point. 19.1, 19.7. Negative 3, negative 2.
You see it's snapping to that collider just fine.
That's not the problem though.
The problem is that its direction is still maintained before.
What I'm saying is I wanted to make sure that these values are updating. So he hasn't. The move distance is greater than that, so he's not going to hit it, I guess, in that frame. But 4 points that. Yeah, that's still on that line. Alright, let's do another update. Now we are on the other collider. Shit. So he was gonna hit the end. Oh, I'm sorry. I'm looking at it wrong. I was thinking to the end of the line. That's right. It wouldn't be till the end of the line. Okay, hold on. Well, I'm just being dumb. I was looking at the wrong thing. Maybe I was looking at something else. Where am I? Why can't I move? Oh, we're still... Yeah, we're still on. Okay, now we're on. Okay, let's try this again. Without me being dumb. Okay, so this update we're definitely going to hit. So we want move distance. We want to see when this is coming in here. Next, okay. So the distance to the surface was 0.03. Our original move distance was 0.06. So that makes sense. We've already circled the playlist. We're going in overtime. Alright. I just want to get through this trace first, and then we'll end it out. So transition to the new collider is true.
It's a good song.
Here. Yeah, it is. The floor angle was 52, but now the floor angle is going to be 0. That's right. That's right.
Yeah.
But you know what went wrong? We're not recalculating our floor angle here. Our floor angle's already been calculated with the current thing. No, but it should come through the next update that way. It should be right. So yeah, our floor angle is 0.
Go into the next update, and then see which value is off. I think it's your floor angle or your direction of the ray.
Yeah, something's not right because here's floor angle, and this does get set to 0.
We may need to make an explicit ray direction equals the new floor angle. Man, somewhere.
Maybe. Yeah. So let me leave the stopper up here, and then we'll go to the next frame. And I'm gonna check 2 things. One, did we get an error? Oh, we did not get an error yet.
Yeah.
So
The
that
problem here is, as you can see, you're going down.
yeah. So now floor angle.
You can see the reverse happening too. If you advance 2 more frames, you're gonna be on the diagonal collider with a ray direction of 0.
So we did move from here to here. So we are on this now. Remember, this is the last frame. So we haven't seen the new updated visual. But we did move to
Yeah,
here.
the ray should not be looking in the down direction.
That's because we're viewing last frame's visual. We're not viewing this frame's visual. We're just viewing the result of that move. So this is not updated yet. But that's why I'm in here looking at the values.
But that might be the problem.
No, this is
I'm saying
one
the
step
actual
back
ray
in
isn't
time.
updated either.
This is one step back in time. So none of this,
Yeah,
all
I
this
getcha.
visual information has not updated yet. So this is last frame.
I get you. I'm saying if the ray is doing the same thing, that might be a problem.
That's what we're trying to check right now. So for direction, got calculated from here. From floor angle. Floor angle is 0. It's 0. A negative 0. Which it just doesn't care about that. It is 0, and the floor direction therefore becomes 1, 0. That makes sense. We're going right. We're going to
Hey,
the
your
right.
velocity?
We are... Walk velocity is nothing because we're not moving this frame.
Can I propose that we have another ray line then for the next frame? Of where we are heading in the future?
What do you mean?
Well, right now, the yellow line is displaying where we've been.
This
instead
is
of
the
where we're
last
going.
frame. We're still not viewing current data. This is last frame.
Yeah. Can we get a
The-
ray?
The ray hasn't even been constructed
ray.
yet.
Ah.
It hasn't even been constructed yet, as far as we've seen. We only got our forward direction. We normalized
So what's
it.
the
I'm second
actual
for it.
raycast saying?
That's what I'm getting to. Just hold on.
Okay.
We're doing step by step. Forward direction is to the right.
Okay.
Our velocity is 0. So, our ray will be a distance of 0 then, if that's correct. Because our combined velocity is going to have a magnitude of 0, I'm expecting. So let's step down to here. But not that one, this one down here. So the move distance is 0. Since the magnitude of moving nowhere is 0. Okay. So our line effectively doesn't exist right now. Our raycast doesn't exist because we're not moving left or right. So our distance to the line end is 0. Maybe this is where it's fucking up. Is this false and this is false? Yeah. Okay. This is where we're screwing up. That's where we're screwing up here. Because we're not moving, but we're telling it there is a distance. We're not setting the distance. Well, that's just gonna set to 0 anyway. Okay, maybe that isn't an issue. Alright, let's step down to here.
So what's the ray doing now?
Right now the ray distance is 0. So we're gonna shoot a ray from our position in the direction of the floor, which is actually correct. This is correct. At a distance of 0. So I'm assuming that we're going to get a couple results at least. We got 3 results.
Snaps.
We got our solid that we're on currently. We got our poly that was what we left, and we got us. So that's correct. We're already snapped to the floor of the box at this point. But that was last frame that occurred. So let's see. Are we going to find all of these things here? So let's see what happens. Our first result is going to be we found ourselves. Okay. Second result I expect is going to be well, we apparently. Wait, why is this null? So this never got set somehow. Or got reset somehow. Okay,
Yeah,
this
that's
is
the problem.
this is the problem. This is the problem. This is getting reset. Move distance is not 0. Hold on. Okay. Alright, that's the problem. I found the problem. We are resetting this immediately after we set it. So we set it correctly, but
Why do we have to no code it there?
because we have to unset it so that once we move away from the point of transition, if we then
Yeah,
move
put that
backwards.
section much later.
Well, here's the problem. Move distance was something when we transitioned from one collider to the other. Therefore, it erases this record.
I know. So, behind the ray?
Okay, here. If we did not transition to a new collider
Right.
and the move distance is 0, let's try that.
There we go.
If that works, cool. Then we'll end it on that. If it doesn't, then I guess we'll still end it on that. I don't know. Yay! Oh shit! Look at that! Look at that shit! Look at it! Look at it! Look at it!
Beauty, man.
Look at it! It's a thing of fucking beauty. I'll tell you what.
Oh no, we gotta go the other way.
And it broke. It fucking broke. Alright, what the fuck? Alright, we'll look at it for like a minute. But I'm not gonna get hung up on it. At least we've got like one side working. That's funny. What the hell happened? Why would it break? What did you do? Alright, let's step through it.
Also, why are we not rendering the debug shape the entire time?
Because we're not close enough to it for the ray to hit it. Floating point error, basically. Okay,
Do a
so
math
we're on it.
approximate.
Oh, it worked, but then we went back to the other line, and then we moved into it. What the fuck happened there? Yeah, that's weird.
I think we made 2 colliders.
Yeah, why did it... what the hell happened there? So we go here. Alright, cool. We're on this line. We're going along.
That's the wrong angle.
That is the wrong angle. I don't know why we're shooting that way. But then we end up going left for some reason.
He's not even on that thing anymore.
I have no clue. It looks like it's perpendicular to it, but maybe it's not.
That's the
Maybe
right
it's
angle.
maybe it's just an angle that looks similar. I really don't know.
It could be the flip normal.
It could be. Yeah, and then you get stuck inside, so you're just stuck.
Do this for me. Rotate the cube, the rectangle a little bit to something else.
I was gonna say, yeah, let's put him to just not rotate it, and we'll see if it works. It's the cell. That was.
It might be that your current code only works for flat surfaces.
That's what I'm thinking. Yeah. Something's goofy when it's not. Nope, it still fucks up. Only in the left direction.
Okay. Rotate the right one. So we can exclude that as a problem.
Yeah. What the fuck? Why does it work on the right side? Why? What the
How about
fuck?
this? Try move these 2 colliders positions.
What do you mean?
The right one on the left, and the left on the right.
Oh, okay. What the fuck? Welcome to coding hell. This is our life now. Yeah, kind of higher than that. Okay, that should. Welcome to coding hell.
The left one.
Yeah, we got it. This one. Solid one. Okay.
Just if your theory is correct, it should be on the right one, not on the left one.
Alright, let's see. It fucking works. Why? What the fuck? Alright.
Now move left.
It's gonna break.
Some
Yeah.
roll space bullshit going on.
Yeah, I don't know. Well, we don't have time to figure it out now, but at least we know that it's for whatever reason, it's just leaving on the left. I don't know. Fuck it. Hey, well, we did good though. We did good. We got from one point to another. We got the right side working. Yeah, we're headed in overtime. I was gonna say that's why I'm trying to call it here. Gets a little freaked out there for a minute, but I don't know. We'll work through it. We'll figure it out eventually.
The right side works perfectly.
Sort of. We don't know for sure. We didn't actually study.
Is this? Hold on. Is this
Yeah.
something that's only in the moving higher code and not in the moving lower code?
Oh, he's not moving correctly. He's fucked. Wow, yeah, he actually fucks up a little bit there. So I thought I saw some sort of weird flip out. Look at this. Look at this.
Yeah, because you moving from right to left here is the same thing.
Watch this, step by step. Okay, so now he intersected. He's on this line, but he actually moves along this line again for one frame, and that's what we saw over there. Except for whatever reason. Okay,
same
so
bug.
then he didn't move at all here, and then he moved along this line but below it, and then he's finally on the line. No, he's above it, and now he's to the left of it. What the fuck? And now he's
not
on.
correct.
Okay, now that one doesn't do anything. Now, yeah, and he's just fucking freaking out until he reaches that, and now he's fine. What the fuck? I have no
I
idea.
think it's something you did. It's only on the moving higher than
Maybe.
or vice versa.
Yeah. It could be something with that. Could be something with that.
So I'm kind of curious. Flip scale inverse That right rectangle.
This one? You want -8x or scale, or what do you want?
Yeah, just invert the sign.
Just one of them or both of them?
One.
Just one. Yeah, same thing. He flips out for a bit. I don't
When he
know.
walks over it. Flip both signs?
Oh, that's gonna mess it up, I think. Oh, I'm sorry. I'm doing the wrong solid, am I? No, I'm doing the right one. Doing the right one. Yeah, same thing. He flips out. I don't know. We'll have to look at it.
So he doesn't care if the index reversed.
Apparently
Interesting.
not. Well, because he's also using delayed data. Remember, if we change it, he's still running on the same points that he thought he saw. So, I don't know. Alright, whatever. Fuck it, whatever. We'll figure it out later. We're already way over time. So, well, we did good. Sort of. We got stuff.
We're almost there.
Yeah, almost. Looking 10 miles down the road. Ah, we're almost there. Well, we'll be there in a month. That's close enough.
Hey, look at that.
Yeah, I know. I just flipped out. But yeah, all right. So we'll post it out.
So close.
So it was fun though, having the collaborative stream. So we figured some stuff out. Maybe we'll look at it tomorrow offline. See what we can find out.
I think we need Bob's help.
Yeah, we need Bob's help.
I mean,
Are you
Ross.
around tomorrow or no?
I'm around.
Okay, yeah. All right, we'll look at it off stream then tomorrow and see what we can figure out. But yeah, for today, I just cut it out. Okay, so we are. Let me get my thing. There it is. Thanks for watching the stream. We're patron funded, and as part of that, we got to read out all the top tier patrons. And we got a new name, and I can't wait to say it. Corporal Chungus is a new patron. Thank you. And we also got Zombie Killer. We've got
Mark, start from the start.
Shut up.
Start and say them all.
Jerry Berry. No, look, I've been waiting to say the words Corporal Chungus all day long.
Yes, but he's the last from the list, so say it again. Let's start.
we got Zombie Killer. We got Jerry Berry. We got AJ, Bryce Nagolinum, and Corporal Chungus. The best name that we have. So thank you guys very much. We will be
Corporal
back.
Chungus.
Or well, at least I will be back on Monday. That's August 5th. And we'll be also
won't be here.
back again on Thursday, August 8th, which may or may not have Tim. I don't know.
Nope.
No? Oh, it won't have Tim. Okay, there won't be a Tim. Tim's not available. So that's pretty much
Bullshit,
it.
man.
We got
I'll be sleeping.
yeah, we got a Discord link down below. We've got a YouTube channel, which you might be seeing this on, and that kind of stuff. So also some of the utilities, those BlizzUtil things that we use throughout the stream, that's a Patreon reward. So if that kind of stuff interests you, check that out. And I'll update it with some new stuff that we're gonna put in there, like the Ray. We'll do a Ray gizmo. And yeah, that's pretty much it. So I guess scrub out, have a good one. Thanks for showing up. And
Say it. Say it, Larry style.
Scrub out?
Almost.
I don't know. I can't do it Larry style. Look, the scrub out
Out.
is my style. I'm the scrub, so scrub out. That's pretty much it. Alright, so see you later, everybody. And we'll talk to you guys. See you guys
See you
next
later.
time. Adios.
Adios. Scrub out.